Hi, today we are going to learn about the applications of arithmetic and geometric sequence, specifically on geometric sequence. So these are the formulas for geometric sequences. Formula for the nth term and the sum of n terms. Moving on to example 1. For the month of June, Ali decides to save 1 cent on the first day of the month, 2 cents on the second day of the month, 4 cents on the third day of the month, and so on, following a geometric sequence. Calculate how much Ali has saved by the end of the month of June. To solve this question, we have to understand what the question wants. Check out the information. The first information is that for the month of June. In June, there are 30 days. Since the question wants you to find how much Ali has saved by the end of the month of June, that means the n will be 30. Because all of the terms are talking about the daily savings. On the first day, Ali saves 1 cent. So according to your sequence, A is 1. And then on the second day, you have 2 cents. He saved 2 cents on the second day. And then on the third day, he saved 4 cents. And so on. The question mentioned that this is a geometric sequence. So when it's mentioned this is geometric sequence, you have no problem but just to substitute into the given formula. The appropriate formula to use is the formula of sums, because the question wants you to find how much Ali has saved by the end of the month. That means the total of the terms until the 30th day. So this is just referring to the sum of 30 days. Once we have the information, substitute into the formula. How to find the r equal to 2? You can do this by T2 divided with T1 or T3 divided with T2. And from here, you can just get 2 over 1 or 4 over 2, and the answer is just 2. Substitute in the values and solve. Final answer is just 10 million ringgit. Example 2. Each year, the price of a car depreciates by 10% of the value at the beginning of the year. If the original price of the article was 50,000 ringgit, find its price after 10 years. Depreciate here means that the price is decreasing by 10%. The original price of the article was 50,000 ringgit. So that's our A. The price after the first year is 50,000 ringgit minus 10% out of the 50,000 ringgit, because the value has been decreased by 10%. Price after 2 years, you can get it by price of the first year minus 10% of that first year. You will get 40,500 ringgit. The question now wants you to find the price after 10 years. We want to find the term after 10 years. And then, since we know that the sequence is 50,000, the second number in the sequence is 45,000, and then 40,500 ringgit, we can find the difference. Is this an arithmetic or geometric sequence? Well, if you try to find the difference, 50,000 minus 45,000, the difference is 5,000. But here, the difference is not 5,000. So that's why we try geometric sequence. What is 45,000 divided with 50,000? From there, you will get 90%, or 90 over 100, or 0.9. This is our R. You can also try to do the same for 40,500 ringgit divided with 45,000, and you get R equal to 0.9 as well. That means this is a geometric sequence with R equal to 0.9 and A equal to 50,000. Substitute into the formula of T to find the terms after 10 years. But what is the N? Is the N here 10 or is it 11? Well, we go through the sequence one by one. The original price is 50,000, and this is, in our sequence, is the first term. So this is T1, price of after the first year, 45,000, is our second term. Price after the 2 years is the third term. So price after 10 years would be T10 or T11. Of course, it would be T11. To find T11, substitute in your values into the formula and then you'll get 17,000. Example 3. A man saves 200 ringgit at the beginning of each year and receives an interest of 8% each year. What is the total amount of savings together with the interest after 15 years? Total amount here means we want to find the sum after 15 years as 15. Let's look at our definition of sums. Let's say we want to find the sum of the first year plus the interest. So the man saves 200 ringgit at the beginning of each year and receives 8% at the end of that year. So this is our S1. He saved 200 ringgit at the beginning of the year, and then at the end of the year he will get an interest of 8%, or 8% can also be written as 0.08. So this is the interest for the first year. This is the savings and this is the interest. You can factorize this 200 and you get 1 plus 0.08. This is just 200 times 1.08, which is equivalent to 216 ringgit. You can write your answer as 216, but I prefer you to do this. Why? Well, we'll see why. The next year, he saves 200 ringgit as well. Saves in second year. And then, in his account, he already has 216 ringgit from the first year. From first year. Plus, he will get the interest for the second year. How did he get the interest for the second year is the total amount that he has saved in the second year plus the amount from the first year is multiplied with 0.08 to find the interest of second year. You do the same thing, you can factorize. Both of these are the same terms, so you just factorize that term. Since you take everything out, you're left with 1 here and then 0.08 behind. Look at the sum after 3 years. This is his savings in the third year. This is the amount of money left in his account after second year. And then in third year, he will also gain interest out of everything that he has saved, which is all of this. And to find the interest, you multiply with 0.08. So that's everything multiplied with this one. You get the interest for third year. We can also factorize since we have the same term. You can factorize all of that out, and here this first expression would be 1 plus with 0.08. 1 plus 0.08 is just 1.08, and you're left with that. Next, we can also expand this 1.08 inside, and that's what you get. After that, you can factorize 200, and that's what you get. Well, why do we do this? Well, that's because we want to find the sum after 15 years of savings. Are we going to do all of this until the 15 years? Well, you can, but it's a little bit time consuming. And we are learning about the geometric sequence topic and also arithmetic sequence. So we can use the formula involved. Well, is this an arithmetic or geometric sequence? To know that, we have to look at the sequence. Can you see the sequence here? Well, that's our sequence. Ignoring 200. Because if you multiply with 200, then we can't see the pattern. That's why, right from the beginning, we did not just put the value as 216. Because if we replace the value as 216, then we cannot see the pattern for it to be a geometric sequence. The second term divided with the first term, you will get 1.08. And also the same if you do it for the third term divided with the second term. That means this is a geometric sequence with r equal to 1.08. Since we know that to find the sums of Sn, will have the same pattern and it will go until 1.08 power n. This is a geometric sequence with a equal to 1.08 and then r is just 1.08. This is the formula for geometric sequence. Substitute it in. Don't forget we have 200 that has been factorized right in front. Just follow from the previous line. And then everything in the parentheses has been changed to a geometric sequence. You can just press your calculator to solve this. Remember, the question wants you to find the sum after 15 years. So it's just S15. Substitute your values of n equal to 15 and you will get 5,864 ringgit and 85 cents. Thank you for watching.